friends, myself Manish Joshi. Welcome all of you in my YouTube channel. In this video we will discuss about the chemical kinetics. This is the chapter number 4th in 12th chemistry, part 1st. Now before starting of the chapter, it is very important to know about the importance of chemical kinetics. In the previous class we have discussed about two important chemical phenomena. The first is thermodynamics and second is equilibrium. The first, which is thermodynamics, is gives only the idea about the reaction is feasible or not feasible. कहने का मतलब ये है कि जो थर्मोडायनेमिक्स ऊष्मागतिकी हमने पढ़ी है वो सिर्फ ये बताती है कि कोई रिएक्शन होगी या नहीं होगी. Then the second chemical phenomena, that is equilibrium, which tell us about what will the conditions where we can get the maximum amount of product. Phenomena can give only the information which we have discussed here. But now the important thing is that these two phenomena is not able to explain the speed of a reaction, the rate of a reaction. Means at which speed the reactant is going to convert into product. So the answer of this question will be explained by chemical kinetics. So we have to study about the chemical kinetics. Now what is chemical kinetics? Chemical kinetics is the part of chemical science dealing with the study of rates of chemical reaction and the factor which affect the reaction rate. Chemical kinetics is the part of chemical science dealing with the study of rates of chemical reaction and the factor which affect the reaction rate. Means the branch of science which deals with the speed of chemical reactions and which type of factor affect the reaction rate. This is all about belongs to chemical kinetics. Now, how can we understand reaction rate? What is the meaning of reaction rate? Rate of a chemical reaction change in concentration, the unit of concentration, that is moles per liter, of a reactant or a product with time, in any unit of time, that is known as rate of chemical reaction. Change in concentration of a reactant or a product with time. जब किसी अभिकारक या उत्पाद की सांद्रता समय के साथ परिवर्तित होती है तो उसे हम लोग रेट ऑफ केमिकल रिएक्शन कहते हैं. So the rate of reaction is equals to change in concentration upon change in time. Now just for example, suppose A is converting into B. Now A here is a reactant and B is the product. So the rate of this reaction will be expressed in the terms like this: minus del A upon del T. Now this minus sign indicates decrease in the concentration of reactant. We know very well that always the reactant concentration decreases as soon as reaction proceed. This triangle sign del indicates change in the concentration, change, and when this change is large we use here this del symbol. This square bracket indicates concentration and the species which mentioned inside it means square bracket inside A, that is meaning is that, or we can say A inside the square bracket, this is meaning concentration of A. Del T change in time, so del A change in concentration of A over time period del T. In the same way, if we want to express the rate of reaction in the terms of product, we can write here del B upon del T. Again del B change in concentration of B over time period del T. Because A decreases with time, so del A is negative, which we have already discussed. So in the terms of reactant concentration, the rate always have minus sign. That is only for indication, that is rate of the concentration of reactants is going to decrease. Otherwise the value of rate is never in negative. Okay, so in this manner we can express the rate of a reaction, speed of a reaction. Just like that, suppose a motorbike cover 1 kilometer distance in 1 minute, so the speed will be here 1 kilometer upon 1 minute. In the same way, we can determine the speed of a chemical reaction, which is technically known as rate of chemical reaction. Now, this is the graphical representation with time how the reactant changes into product. Look at here. This is a reactant sign, black sphere. After some time, the reactant convert into product, which is symbolized here by red sphere. As soon as the time passes, the number of red sphere increases, means the concentration of product is going to increase there. So in this manner we can understand how the reactant concentration decreases and the product concentration increase. Again, rate is equals to negative del A upon del T, rate is equals to del B upon del T. This is the graphical representation. The number of molecules, this indicates concentration, and this axis, x-axis, indicates time. With time, you can observe that there are two lines. This is one is black line of the graph, second is purple line of the graph. The black line indicates reactant molecules, and you can observe that as soon as the time passes, the concentration of reactant decreases. The other side, as soon as the time passes, the concentration of product increases. So we can understand that with time the concentration of A decreases, and with time the concentration of B increases, means product concentration always increases with passage of time, and the reactant concentration always decreases with passage of time. Now, reaction rate and stoichiometry. To get a unique value of rate of a reaction, the stoichiometry plays an important role. So to generalize the reaction, suppose A plus B convert into C plus D, and small a, small b, small c, small d are the stoichiometric coefficient, then how can we write the rate of reaction? So for the generalization, or to get a unique value of a rate of the reaction in terms of all the reactant and all the products, we should divide the stoichiometric coefficient in the rate. So rate is equals to minus 1 upon small a del A upon del T is equals to minus 1 upon B del B upon del T is equals to plus 1 upon C del C upon del T is equals to plus 1 upon D del D upon del T. You can observe that each and every reactant gives the rate equals to the other reactant or product. This is the important thing, that why should we divide the stoichiometric coefficient with rate to get a unique value? It means the rate of reaction is always same for all the reactant, all the products. It cannot be different for different reactant or different product of a chemical reaction. So we use here stoichiometry. Now this is another example how can we involve the stoichiometric. Okay, this is general reaction. A plus B convert into 2C, so the rate of reaction will be here minus del upon del T, because the stoichiometric coefficient is 1 is there, so no need to write, is equals to minus del B upon del T. Again the stoichiometric coefficient is 1 is there, so no need to write again, and last the stoichiometric coefficient is 2 there, so we have to write 1 upon 2 del C upon del T. Now one more example is there, decomposition of nitrogen pentoxide. When nitrogen pentoxide decompose, it gives nitrogen dioxide plus oxygen. When we balance it, we use here stoichiometric coefficient 2, 4 and 1. So the rate of reaction will be here minus 1 upon 2 del N2O5 concentration upon del T is equals to 1 by 4 del NO2 concentration upon del T is equals to concentration of O2 upon del T. One more example, that is 2HI convert into H2 plus I2. So the rate of reaction will be here minus 1 upon 2 concentration change of HI upon del T is equals to concentration change of H2 upon del T is equals to concentration change of I2 upon del T. One more thing, again this is negative sign, indicates decrease in the concentration of reactant. One more example here, 5Br minus plus BrO3 plus 6H plus convert into 3Br2 plus 3H2O. So if we want to write the rate of the reaction, it will be like this: minus 1 upon 5 change of concentration of Br minus upon del T is equals to minus change in the concentration of BrO3 minus upon del T is equals to minus 1 upon 6 change in the concentration of H plus upon del T is equals to 1 by 3 concentration change of Br2 upon del T is equals to 1 by 3 concentration change of H2 upon del T. So in this manner we can use stoichiometric coefficient rule to determine the unique value of rate of reaction or reaction rate. Now there are two types of rates. First is average rate and second is instantaneous rate. So the first concept here is average rate of reaction. Now first thing is that where we can use the average rate. The average rate concept can be used where we want to determine the rate of reaction by using the two different points, two different concentration and two different time interval. In that situation we have to use average rate of reaction. So finding average rate of reaction. Rate of reaction is a measure of how fast a reaction occur or how much the reactant or product change in product period of time. So rate of reaction is equals to quantity change of reactants upon product, means concentration, upon total time for the reaction. To understand this concept, there is a problem based on the average rate, that is NCERT INTEXT question number 1. Now the question is, for the reaction rate convert into product, the concentration of a reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Calculate the average rate of reaction using units of time both in minutes and second. So average rate is equals to minus del R upon del T. Del R change in concentration, it is changing from 0.03 to 0.02. Mention here 0.02 minus 0.03 upon del T. In final time minus initial, 25 minus 0, that is 25. When we solve it, the answer will be here 4 into 10 raised to power minus 4 moles per liter per minute. Time is equals to 25 minutes is equals to 25 into 60 second. Put the unit of time at the denominator side of the formula. Find out the answer: 6.67 into 10 raised to power minus 6 moles per liter per second. Now one more question is based on the average rate concept, that is NCERT INTEXT question number 2. In a reaction 2A convert into product, the concentration of A decreases from 0.5 moles per liter to 0.4 moles per liter in 10 minutes. Calculate the rate during this time interval. So rate is equals to again minus 1 by 2 del upon del T. Why we use here 1 upon 2? Because here the stoichiometric coefficient is there 2. So to get the unique value of reaction rate, we have to divide it by 2. So minus 1 upon 2 change in concentration 0.4 minus 0.5 upon 10 minutes. Now calculate, the answer will be here 5 into 10 raised to power minus 3 moles per liter per minute. Now the second is instantaneous rate. What is the meaning of instantaneous rate? Suppose we want to determine the rate of reaction at a particular time. At that time the rate is known as instantaneous rate, and this can be done by the slope of a line tangent to the curve at any point is the instantaneous rate at that time, and the value of instantaneous rate is very small. So in spite of using del sign, we use here small d, that indicates small change in the concentration, and this express instantaneous rate. So it will be here dA upon dt. If we use del A upon del T, that indicates average rate. If we use small d concentration of A upon dt, that will be instantaneous rates. Again, to calculate the instantaneous rate, we have to draw the slope of a line tangent to the curve at any point in the rate of reaction graph that indicate instantaneous rate. Now look at here, this is the graph for product and with respect to time. This is the curve of the product molecule. We can choose any one point at here. Suppose at this point we want to determine the rate of reaction, so we have to plot a tangent on this line and we can select any 2 points on this tangent to convert into a triangle, right angle triangle. By using this y-axis indicates change in product concentration and this x-axis gives the change in the time. So the instantaneous rate will be here dp upon dt. Okay. The rate of reaction changes from time to time as reaction happens. The rate of reactions at a particular time is called instantaneous rate. The instantaneous rate of a reaction is equal to the gradient of tangent at a particular time. So rate of reaction is equals to del p upon del t, that is average. In spite of this, we can use dp upon dt. Why we use here del p? Because this difference is greater at this axis, so we use here del. But whatever rate of reaction we find out at this point, that will be known as instantaneous rate of the reaction. Now this is one more example. This tangential line, we can draw any 2 points to convert into right angle triangle. Now this is again the graphical representation, concentration with time. This is decreasing concentration of reactant. This dotted line or fragmented line indicates increasing concentration of product. Now concentration and rate. What is the relation between rate of a reaction and concentration? Each reaction has its own equation that expresses its rate as a function of the concentration of the involved species, reactant, product or catalyst. This is called rate law. Means whatever expression we write for the rate of a reaction to indicate the concentration of reactant and product, that is known as rate law. Now rate law expression, we know how to work out the rate of the reaction, but that does not tell us if all the reactant make the same contribution to the overall reaction. That's where the rate expression comes. Suppose x plus y convert into z, then x may make more contribution to the rate of the reaction than y, or x may make no contribution to the rate of the reaction. Instead, it depends on y. This only way to find this out is through experimentation. So rate expression can be determined with the help of only experimentation. Now rate law. In general, rate of reactants in general, rate of reaction increase as concentration increase, since there are more collision occurring between the reactants. It means when we increase the concentration, the collision between the reactant molecule increases. So when the collision increases, the rate will be increases. The overall concentration dependence of reaction rate is given in a rate law or rate expression. How the reaction rate depends on the concentration, it expressed in the terms of rate law or rate expression. For reaction follow simple rate laws. Suppose V is equals to K A power M B power N. A and B reactant concentration. The exponents M and A reaction order with respect to specific reactants. What is the meaning of reaction order? We will discuss in the upcoming videos. The constant K is known as rate constant. And the overall reaction order is the sum of the reaction orders M plus N. If we want to determine the order of the reaction, that will be the sum of the concentration power of all the reactants, which has been expressed in the rate law expression. So this is the meaning of rate law expression. Rate law expression gives the idea how the rate depends on the concentration of reactant or product. Now rate expression. When you see square bracket around the formula, it means concentration of HCl. Means whatever species has been written in the square bracket, it means it indicates concentration. So we could say that the rate is proportional to the concentration of the reactant. Rate is directly proportional to concentration of X and concentration of Y. Rate is directly proportional to X and Y. It means this suggests that X and Y both have an equal effect on the rate of this reaction. Now the question is, what would happen if we double the concentration of X or Y? The rate of reaction would also be double. Now the another question is, what would happen if we had Y power 2? It means doubling the concentration of Y would quadruple the reaction rate. Quadruple means 4 times. The meaning of this slide is that whatever value has been expressed in the rate expression, that will decide what will happen or which type of effect will be made by the concentration of reactant on rate. Now rate constant. Unfortunately, probability signs are not very useful to us, so we need to replace it with a constant. In the previous slide, we have this one, rate is directly proportional to x and y. So when we remove this propensity symbol, there is a new constant which is known as rate constant. K is the symbol of rate constant, and the definition of rate constant is very interesting. If the concentration of all the participating species is unit, means the concentration value of x is 1 and the concentration value of y is also 1, in that situation rate is equals to k. So the rate of reaction when the concentration of all the participating species is unit, that rate is known as rate constant. This is the definition of rate constant, and it have different properties, like k is different for every reaction, k varies with temperature, so temperature must be stated when quoting k. So in this manner, dear friends, we have discussed about what is the meaning of chemical kinetics, what is the importance of chemical kinetics, what is the meaning of rate of a reaction, how can we express rate of a reaction, what is the meaning of average rate, how can we calculate, what is instantaneous rate, how can we calculate, and what is the contribution or what is the significance of rate constant. The rest of the things we will discuss in upcoming video. Thank you so much.